so glad to have you here with my coworker Tracy. We work for Fort Worth Water Conservation, and tonight it is our absolute privilege to present to all of you a brand new course, a brand new class. And we'll introduce our fabulous speaker in just a few minutes. For those who have not joined us, we are like a little family here on Thursday nights, and so we usually get to know each other a little better. Sometimes we have some family fights. So for this, we do trivia. And our trivia is generally pretty silly, not as always as scientific as you might think we could go. However, tonight we might blow your mind. And so for those joining us, on your table you will see a small water droplet. Those are our water wobblers. Say that, water wobblers. And we ask that as you sit at the table, so that our volunteers and myself don't get as overwhelmed with so many hands going up, to be fair, that if you are going to try to answer the question, you must have the wobbler in your hand and raise him up, or her. Okay, you must raise him up, okay? And so up for grabs tonight, we have our fabulous 20-ounce Arctic mug. This is a hot, cold tumbler. And then our new, this season's 40-ounce tumblers. These are new navy blue to match our Fort Worth water. You guys are so good. And then before we get started tonight, for those not able to join us in person, we are giving away some pretty cool new giveaways. These are new for 2026, and of course we plan on bringing these back for our next water savings seminar as well. These are our Cease the Grease containers. These containers are silicone, reusable grease containers. As we are talking about drains, and garden gains, we would be remiss not to talk about drain and fats and oils and greases that go down them. It's one of the major problems that Fort Worth Water faces. Those wonderful bacon dinners that you're making for breakfast, we love that for you, but then it goes down the drain, it solidifies, and it is a very big and expensive problem to fix. And so, in an effort to help reduce the fats, oils, and greases going down your residential drains, to keep your drains protected at home, save you money and save us some money, we are giving out these new Cease the Grease containers. So, if you are in the kitchen, I mean, whether you like to be in the kitchen or not, but these are available. And again, if you did not get one tonight, please let me know. We will have these available for pickup at City Hall. I'd be more than happy to meet you and hand you guys off some. Yes, ma'am. Question about.
Quick question: if it's reusable, how do you get the grease out?
So you're flexible. You actually let your grease. That's great. What a great question. The question is, how do you reuse these over and over again? So there is a strainer on top inside the Cease the Grease holder, and that can stop any large particulate. So if you are cooking eggs and bacon and don't want the eggs and the bacon grease to go through, this will catch that egg particle. Inside the grease container, you'll see it's very flexible material. What you'll do is you'll let your fats, oils, and greases harden in here instead of hardening in your drains, because believe me, it happens to the best of us. And then once it solidifies, you simply pop it out into the trash can just like that. So you don't have to keep a glass container. I have a 5-year-old at home. We try to keep glass off the counter. This is a nice alternative. It also stays completely sealed. Even when it's closed, it seals, so you don't have to worry about odors in the kitchen. So this is a great option. So do protect your drains. We care deeply about our fats, oils, and greases in our water lines. So that is new this year. In addition, for those joining us, you guys get some sweet swag tonight. We have our brand new, I know, dual usage, our hose extenders, our hose arms, if you guys would like. These are great this time of year. You are allowed to hand water your yard at any time, any day right now. That is in compliance with the Fort Worth irrigation ordinance. And so we wanted to give you guys a boost to be able to do that a little bit more comfortably. This does have a quick connect. You simply can pull the end of this hose off, and it has a regular screw on the inside, so it will attach to any standard garden hose. If you need any help before you leave, any of our volunteers can do our best to show you how this works. So let us know. And then finally, you guys are getting the all-new, brand new buffalo leather gardening hose. We're so excited. We are super excited to be able to order these this year for you guys. guys. These are a very tough leather glove. I can tell you that me and my 5-year-old have been putting them to the test. Well, so far so good. Are they going to get dirty? Absolutely, but they should be. Other than that, they're a great product. So we're excited to offer these for you guys tonight. So without further ado, I'm going to jump into trivia, and then we'll let Jon get started with his course. So prepare your water droplets. Remember, remind your table mates that we are friends. We are we are all here to save water. We are saving water. We're not throwing our water bottles in our Okay, so speaking of drains, and artists, the first water pipes in the United States were not metal. What type of material were they made of? Special bonus if you know what
This guy.
Clay.
not clay.
The lady in the back. The lady in the back.
Not clay.
Then right here.
Stone.
Not stone.
I didn't catch the next one.
Wood is the answer. I'm gonna let, all right, so the answer was wood. So specifically, it was fire, charred, log wood. They made a form this is a serious one, and this is serious because we're actually giving away tonight brand new high efficiency Kohler three-stream shower heads. These are amazing, or three-setting shower heads. These shower heads that we're offering tonight can save you on average of 2,700 gallons every year after installation. That adds up to a lot of savings of water. Updating the shower heads is a really good way to reduce the water bill, of course, keep our lakes and our reservoirs full. So with that being said, a leaky faucet, which includes a leaky shower head, can waste over how many gallons of water in 1 year? I'm going to get to the closest. 100. We're starting in the thousands. 16,000. We have a big, you need to get on my H2O. If you're leaking 16,000 gallons of water, if you experience a trigger of leaking 16,000 gallons of water, I need you to call Tracy and we will get on my H2O. We will look at that smart meter data and we will get to the bottom of that one. So 16,000 gallons is too high for a very slow. I'm sorry? 6 family houses.
There you go.
We don't leak in Fort Worth. We're leakless. Yes, ma'am.
6,500.
6,500. A little bit
Right here.
lower.
1095.
No, we're going below 6,500.
Yes.
But we're above 1,000. You were the closest, but you were still a little too low. We gotta get it.
What'd she say?
We have it. 2,600. So yes, so a leaky faucet and a leaky shower head can both waste up to 2,700 gallons of water, and that may not seem like a lot when you see that little annoying drip. You might think, and I'm 100% guilty of it. I'm sorry, before I worked for water, I was so guilty of a leaky kitchen faucet. Man, the way our bill was impacted by fixing that, what an investment. So if you don't have a recently upgraded shower, or if you'd like one, we're happy to give them away over there. And of course, you can always request one free from Water Conservation by contacting Tracy or I throughout the year. And they're available on a first-come, first-served basis, but we usually have one, so that's a good option. Okay, last question. This is a bad pun. I don't think I can say this to these people without laughing, so I'm just going to do this. Okay, I'm going to say this. Raindrops. Here's your meteorology question of the day. Raindrops, despite our very adorable wobbler on your table right now, don't actually fall out of the sky as a teardrop shape. Whoa, whoa, we're having some rain blown already. I love this. What fast food item does a raindrop actually look like as it is falling out of the sky?
French fry.
It's not a French fry. You are on the right track.
A burger?
It is a hamburger.
A
Congratulations.
Right now, yeah, no, come on up. You're welcome to. We'll get you on camera so everyone can see. That's absolutely fine. Okay, and then I'm going to go ahead. So this is our one warm weather one. Warm water cooler, and these are cooler ones. They can also be these hot. That's a really hot one.
This is a hot one?
That's hot. This is cold. They're both adorable. They're both highly sought after. Tracy and I, everyone always tries to take ours. Enjoy. Thanks for being here. Okay. For everyone who's wondering, the next class is going to be June 11th, Thursday, June 11th. Here at the Botanic Gardens, we're doing Smart and Sustainable Landscape Design with Heather Bass from TRWD. I got to be real honest, Tracy and I, life is lifing for us this week, and so for the first time ever, the class will not be available at 8 o'clock tonight to sign up for. I know, ooh, so sad, ooh, I know, but Tracy and I will have that class up and live tomorrow, as soon as we get to work, and we will also be emailing it out to all of you directly, so you still get first chance to get notified when that becomes available. So if you'd like to join us June 11th, Thursday, from 6 to 8 p.m., it'll be here with Heather, and maybe someone's been growing some plants at home, so there might be some live giveaways for that. We'll see. We'll see how Mother Nature treats those plants. Let's see. Okay. Without further ado, thank you for listening to my bad mom jokes and for putting up with our silly giggles here. I'm going to introduce to you this wonderful man who walked into conservation's life about a little less than a year ago. Jon Kirk, is a senior design associate with Land Visions in Tyler, Texas. He brings 18 plus years of irrigation experience and 29 years in civil engineering to all of his projects. Known for solving complex irrigation and drainage challenges, Jon backs his work with top industry credentials, including licenses in Texas and Louisiana, Smart Water certification, CLIA certification, EPA Water Sense partnerships we are big fans of here, and even some U.S. patents, pretty good stuff. So he leads with a simple philosophy that you need to understand the why before choosing the how, and then bring the team together to create smart, sustainable solutions, preferably with time left for a round of golf. So, there you go. So with that being said, I'd like to introduce you all to Jon Kirk.
Thank you so much for having us. I have a little bit of trivia, but it's a simple one. So this is our third time in Fort Worth. The first two times I did a couple of drip classes. And the first one I did was over at the Botanical Center, and I was 10 minutes into it and the power went off. So I had to wing ding it. And so that, it happens, but we went through it and we got through it and it was good. And I think people learned a lot about it. Excited about the class tonight. I'll just give you a little bit of preview. I will come back in July 9th and I will teach an irrigation class as well. It won't be just drip, it will be all facets of irrigation. So, but tonight we're going to concentrate on drainage. So my question to you all, so I can kind of see where we are, is how many of you actually have actual drainage problems now? Yes. Okay. How many of you think that you're going to be able to tackle it on your own with a little bit of education? Okay.
Jon, sorry, a little bit louder.
Okay. And if not, and you're going to hire it out, at least you'll get some information to talk to your contractor about, so that you'll be informed, so that whenever you're discussing certain situations, that you know that either you're being told the right thing or not, and which devices are used in the right application. So we're going to do a little bit of on script, and I'm going to pull off script some because I have some examples here. And I'd like to, when I get to a point, I'd like to hold them up and show you what I'm talking about, so that you can see something visually with what I'm referencing to in my presentation. Okay, so this course is intended to introduce you to an understanding of what is involved to successfully drain any part of a feature, a noticeable or important characteristic or part that may have an important impact on infiltration from water flow. So we're talking here about your lawn, we're talking about beds, we're talking about your roof. All of these contributory factors combined in aggregate form will amount to a lot of water in your landscapes. So the objective at this time will be to convey attention to site generated problems as well as plan design considerations. And that's what this would be the fun part. Okay, so first and foremost, before you can begin to understand situations where there is a drainage issue, you must fully engage with the surroundings. Meaning, you're at home, and let's say that you're having issues, but you don't know exactly 100% where the water is coming from. I tell everybody that you have to stand and look, and you have to literally look all the way around to get an idea of where areas of water infiltration may be coming in from. And that's how you're going to better identify and acknowledge the situation and come to a reasonable material to drain that situation. Let's see. Sloped areas and bed drains, piping culverts, downspouts, swells, roof areas, pervious and impervious areas, vegetation, etc., and the magnitude of the impact. So that's the majority of the items that this is going to affect. Water does move uphill as well. Water will also seek its own level, and it also takes the path of least resistance. So with most issues, whenever I get a phone call, I have water in my basement, or I have water this or that, it's because water just has a mind of its own, and it's going to go where it wants to go. And so the idea behind all of this is going to be taking the unwanted water, capturing it, and moving it somewhere else where it will not affect you in your landscape. Leave nothing not investigated. Take measures, pictures to help you go back and build your case and substantiate your thought process. So this could be very important. You go out there, let's say it rains really heavy, and if you can weather the storm, go out there, take a picture where the water is ponding and settling or eroding out. This will help you identify it a lot easier. Oops. Here's some examples. You know, if you need the water, great, but if you don't want that, then that's a problem. Right?
Boo! That's wasting.
I'll tell you, this picture right here is probably 75 to 80% of problems that we have at homes with guttering. Let's say it's a new house, the contractor will put the guttering and the downspouts on. It doesn't mention anything to the homeowner about, hey, we could take and pipe this and get this out of here. And it's just an added cost that maybe they don't want to spend. So this is the majority of a problem. So sometimes this is actually obviously in a yard area, but this could be the same thing in a bed area. So now you'd have a plant and mulch and everything else. Well, we know what's going to happen there. That water's going to come out there with some velocity, and it's going to just scour the mulch out, and your beds are going to be just all marked up. And then somebody missed this one. This is an actual picture, so believe it or not. So that's supposed to be the low point, but now it's the high point. So you really got to get a lot of water in there for that to somewhat go on, and then when it stops, that's when it recedes. That's what you're going to end up with. So that's not good either. And then you have this situation, actual picture. I scratch my head and I'm thinking, what in the world is going on here? If you have something like that in your yard, or if you have a contractor that's going to do something like that, man, you better run.
You better call John.
Okay, so first and foremost, I have to tell you this. So the TCEQ has a specific law, which is 11086. 11086, obviously there it says that you can't take your flow or captured flow and discharge it onto an adjacent property. That is a huge no-no. I can tell you for a fact, without going into specifics, that in Tyler, I have 2 projects that I'm on hold because I'm in litigation, right? I'm not in litigation, but the property owners are in litigation because of this very thing, and this is a very serious thing. And so, it's not so much that you want to upset your neighbor, but it's just, you don't want to get into a lawsuit because you've taken water and dumped it on your neighbor's property and it has caused substantial property damage. That would be a bad thing. So that's basically the outline of that right there. Pretty cut and dry. If you want to look it up, look up Water Code 11086, and then it'll tell you specifically what you can and can't do. So when does liability arise? So liability often arises when the landowner modifies the property's grade, elevation, or landscaping in a way that increases or directs the flow of water across a boundary line. So sometimes you'll have a subdivision where somebody's come in and they've built a lot up higher than everybody else. Well, now they've created, excessive runoff onto other people's property instead of capturing the flow, maybe discharging it to the street or to the curb or to the a creek or something like that. So we're talking about drainage. So just to kind of dial in what drainage is, it's a natural or artificial removal of surface water and subsurface water from an area with excess water. Drainage systems are designed to quickly remove water, resulting in a relatively high flow rate compared to natural water bodies. So this can be set up as a comparable to a pre-development, post-development type situation. So let's say we go back many years. We have this field or some landscape, and it's natural. And so as it rains, the land takes care of the water on its own, right? So the infiltration rate is probably good because the soil's not compact. The water seeks area of the path of least resistance and low pressure, so it's going to automatically mitigate to a creek, to a little point, to something on its own. Then you come in and someone's going to build a road, a building, a shopping center, anything that's going to have a lot of impervious cover. So imagine that raindrop from when it's pre-development and it drops, it's going to hit and it's going to be absorbed or run. In post-development, with all that concrete and metal and everything, when the raindrop hits, right, it's going to automatically take off. So you have an accelerated velocity of that raindrop because now it can't be absorbed. It has to run and find the lowest path, either an inlet or a curb cut or something where the water goes out. And that's why you see in shopping centers and anything that's developed in a heavy rain, there's a lot of flow going across that parking lot. Water characteristics: water always seeks its own level, as we discussed. 1 gallon of water weighs approximately 8.33 pounds, so it's pretty heavy for 1 gallon of water. Water is typically measured in gallons per minute or cubic feet, and that's an important buzzword, GPM and CF. The speed of water is measured in cubic feet per second. That's velocity. Water can move uphill under certain conditions, such as through capillary action. So if you have soils that are conducive, such as soil that shrink and swell, that have a high, what's called a plasticity index. It's the amount of water that goes in, or it causes it to swell and become fill capacity. Water can move uphill as that clay soil starts to expand fill capacity. So soil and water relationship. So what is soil? Soils are a mixture of inorganic solids, air, water, and microorganisms. All these phases affect one another. How soils react to water induced by rainfall and irrigation will influence your drainage parameters. So to break it down a little bit, let's say you're going to put a bed in at your house or your lawn, but let's do the bed first. And you dig down in this really horrible soil, and you say, well, I'm going to cut it down and I'm going to pull this out. I'm going to import really nice soil in there so that it can give my my shrubs and flowers and a good start, so their feet will be really great in the soil. But what happens is sometimes because of all of that makeup in that soil, what is now become undisturbed becomes basically a bathtub for what you just put in for the good soil. So if you put water in there, it's going to go down, it's going to soak up in the good soil, but as it gets saturated and runs down to the bottom, it'll want to sit, and if it's clay, it'll swell up and then it goes nowhere. So now you have water sitting in your bed. Same thing with the lawn, right? If you cut your grade out with bad dirt and pour good topsoil, and you put the grass down and you roll it, you water it, it looks good. Underneath that profile is still a hard pan, right? So you have to overcome some of the challenges with soils in your landscape. Soil function is, the soil basically acts as impervious medium that provides passageway voids in the soil for water to move into the subsurface. The effectiveness of the soil to transport water depends upon the size and permeability of these passageways. So again, big chunky soil passes water easier than tightly compacted soils. Soil compaction, how tightly packed the soil are, depends on the size of the soil particles and the volume of the traffic traveling over the area. So let's say in your yard, right, you don't get in your yard very much, so your compaction is probably very low. But if you have a yard and you have kids and you go out and play and you're running around in it, you don't realize that over time you're really slowly just compacting that soil down under the grass, right? And so that's why aeration is important. You know, it pulls the plug out and lets nutrients, air, water get in there for a deeper percolation into that long area root depth. So, you know, as you walk off a path in the dirt and this, that, and the other, over time, if you did enough, you're really compacting that soil. New construction is horrible about it. That's why tree protection is very important. If you have trees that you want to protect, and it usually has a barrier around it that says, hey, don't get any closer to where the drip line of the tree is, because that's where the important roots are. Because if you start running over that, you're compacting that. If you start piling up dirt on top of that tree, you're compacting it, you're going to end up killing that tree. So that's important as well. Soil and water relationships. So soil probing and analysis. The best way to determine drainage needs in the site analysis stage is to probe and analyze existing soils. You can buy probably most of your landscape supply companies. It's a soil probe, unless you already have one. It's basically yay big, and it's got a half slot on it, and an open on the bottom, and a T-handle. And you can go out and probe. You can just kind of wiggle it down and then pull it up, and you can actually see the strata of that soil and exactly what's wet, what has roots, where if there's anything in a soil change that may, like this is like clay and this silty sand or something like that, and you can see exactly what that's all about. So if you're going to make any changes to your landscape, you can use that as a benchmark to say, wow, I got a lot of clay, I need to dig down and get that out, or I don't have hardly any clay, I just really need to just, you know, maybe take out a few inches off the top, import some good things in there, and till it all in, we're good to go. But that's really important, because that's also going to be the characteristic of how much water that soil holds. Vegetation influence. So vegetation influences the soil in many ways. One, the denser and larger the vegetative cover, the more rain or irrigation water will be intercepted and not reach the soil surface. Two, the presence of deep-rooted vegetation tends to improve soil structure, which increases infiltration. Thirdly, heavy vegetation can help retain moisture. Most importantly, vegetation decreases or prevents erosion. So it's like anything. If you have a field, a meadow, whatever, and it's thick full of grass, right? Then it's going to be basically the third of the category of the vegetation. On a slope, if you have a lawn, it's basically going to be a light vegetation, right? So it'll get wet and it'll want to run off. Not so much infiltration on that. So your vegetation, your plant material does have a lot to do with how much water is actually absorbed, used, or runs off. And this is what I was talking about earlier, the plasticity index. It's a PI. That's how much soil the soil will hold water. Clay holds more, sand holds zero, just about. So this right here, we're gonna start talking about some specifics, but before we get into this, does anybody have any questions about the first part we talked about? Soil, water relationship, anything like that, right off? Yes, ma'am.
I don't know if it's a questions, well, okay, the question is, will you cover how to connect that soil from the plants and the subsoil or the top that you talked about? So that that problem doesn't exist anymore?
Well, it will always exist, because if you have a lot of clay, right, and cut it out, and you put in good soil, you're still gonna have the clay behind it. You really can't connect the two soil types together, because one has always been there, which is undisturbed. You disturb this portion of it, and it will set on the bottom of the undisturbed portion of it. So that's why, by doing this and having proper drainage in there, you can drain that water out of that and not have it sitting in there and actually, doing root rot to the plants and causing disease.
So if you have so much of clay, you want to make it an area where you can have the vegetables or something.
Yeah, and
You really literally have to dig it out.
well, that's kind of a good method to do, but if you wanted to take a little bit different approach, you could take, say, sand, something chunky, and put it in there and till it in there. What you're trying to do is you're trying to get that clay also to release and bind to something else so that it becomes loose. So if you do that, you can break up that solid clay, you can break it up into something that's more manageable. And over time, it should, as the plants get bigger and start to grow out, it should break that down a little bit more. But I think that if you didn't want to do all that digging, you could put something in there that's more granular, and it would help loosen all that clay up.
You can put soil in there.
Yeah, you would want to make sure you have something that has some substance, not just topsoil, something that has some sand.
Are you talking about like soil conditioner?
Yeah, something like that, or like a rose mix or something like that that has particles in it that you put in. Yes, sir.
Trying to think of the name of that, looks like river rock or gravel, expanded shale.
Spanish shell, you can probably,
That's something that's been promoted by people that seem to know what they're talking about. I've never used it. I've seen it. It looks like black pebbles.
yeah.
So that, for some reason, that is supposed to be very good about breaking up clay soil.
Yeah.
That better than sand. I use compost and
Right.
work it in. And I have a vegetable garden, so they get work every year. When you put in a perennial garden or shrubs, you're not going to be digging it up every year.
Right.
You want something a little bit more, but you can also use compost.
Yeah, anything like that, anything that's granular, you can put it in there and till that up, and that will help loosen and fluff that up a little bit, where it drains a lot better. Okay, so this is where we're gonna kind of get into some specifics about how to lay out a drainage pattern in an area and a plan for drainage. So this is actually a plan that I did, and I thought, well, I'll just stick this in here. It's a lake property. Obviously, there's the boathouse. The lake goes here, and you can see all these lines. These are the trunk lines that's picking up every bit of this on this house. That includes downspouts, beds, the area that drains. Here's a retaining wall. There's a French drain behind that. Anywhere where these purple lines are, that's a French drain. So it has basically all of the features that you would probably come in contact with if you have a property that has any number of these things. So this is where we're gonna kind of start figuring out how we're gonna do this. And I thought about this, and I want to give you as much information as I can, but I'm gonna keep it really simple so that there's no high-tech mathematical equations. I've done all that, so I'm gonna break it down. So when we do this, we're using what's called the rational method formula. And so what this is, obviously, is the formula is Q equals CIA, which Q is the runoff in area in cubic feet per second. That's peak flow. C is the coefficient of runoff. We'll talk about that's the type of runoff. That's going to be whether it's grass, concrete, anything like that. I is the intensity of rainfall. I use 4 inches an hour, and I'll explain that. And A is the area to be drained, usually measured in acres, but I use square feet. So to make this happen, your Q equals CIA divided by 6.23, which is the constant to convert cubic feet per second to gallons per minute. And this is what we really want to do. See how many gallons a minute is flowing, and if it's flowing and standing, about how many gallons we have. So this is the runoff coefficient I was telling you about. So if we look at this, this is the most critical aspect to identify what type of soil texture do we have, number one, and the equivalent coefficient of runoff is a number that we use to plug in to figure out where we are. Right, so this is also known as the C factor. Rooftops, concrete sidewalks, asphalt parking lots, roads, etc. refuse to let water pass through them, which is impervious, right? And consequently the water that hits these surfaces. So again, anything up here like this includes metal roof. That's your highest C value that you're gonna get. And then the lawn areas is 0.35, so that's really pretty low. And then if you have basically, let's say you have a gravel drive, a gravel path, but it gets some water on there, you can use any one of these if you have light vegetation or dense in there, but if it's bare, then it has a little bit higher because it's approaching that impervious level, but not quite. So, and then here again, your clay values are pretty high up in that area. And then sand is always gonna be in the lower portion of this. Okay, so now this is going to be this is a chart that is important because this is going to tell you basically how much water these pipes can flow effectively without causing a tailwater situation because you try to jam or run too much water through the pipe without upsizing the pipe accordingly. So I use, in my designs, 2 feet per second. That's typically what I use on everything, even in a 4 inch per hour rain event. And it's pretty good because the thing about it is if you look, a 4 inch pipe on that 2 foot per second, it'll do almost 80 gallons a minute. And so when you think, that little piece of pipe right there, you get about 80 gallons a minute right through that pipe. No problem on a slope. All day long. And not effective. And then here's your soil triangle. So the soil texture triangle basically is a good thing to have because if you really don't know what kind of soil you have, you can go out there and grab a handful of it, compact it, squeeze it tight, open it up, look, and see when it kind of falls apart, if it falls apart, about how much of 100% do you have that equals, in 3 phases, right? So, if you have, let's say that you had, you think you've got, 50% of that is being, silty loam right here, right? right? You come up, you project over, and they say that you think you got, oh, I don't know, maybe about this much in silt, and then it jumps across, and you think, well, I got maybe a little bit higher compact, maybe 50% clay. So you're trying to dial this thing in to kind of see where does your type of soil falls, right? So if you're doing something like that, you may fall into clay, or maybe in a clay loam area. So you still have clay, and maybe a little bit of good dirt in it, but maybe not as much as you'd like to be like that in this area. So that's when an amendment would come into play and help you take this from here down into here. So that's a good tool. That thing's been around forever and use it all the time. Okay, so this is the methods of drainage. So we have two methods to classify a particular drainage situation. First, there's surface, and then there is subsurface. So let's look at both of these. So the surface drains refers to removal of surface water by the development of the slope of the land, utilizing systems of drains to carry away surplus water. And subsurface drains, or subsurface drainage, describes the process of removal of that water which has infiltrated into the soil more than the amount that can be held by capillary forces against the force of gravity. So the typical methods that we're going to drain undissolved surface water and subsurface water are, everybody has heard of French drain, obviously, that's subsurface. Area drains, speed drains, and I'll show you what these are in a second. Believe it or not, inspection tubes and tree wells are subsurface, and that's kind of important. If you have a lot of trees or newly planted trees, and you want to make sure that if you think that area's getting a lot of water, but you don't want a lot of water to be down inside that, down in that root ball, so it'll lock that tree out, you just put, honestly, an inspection tube, something like this, or a perforated pipe, you put it down, you put a cap on it, and every once in a while, you can open that thing up and look in there, and you can see, if you see water in there, or if it's like up in the pipe, that's a lot of water. You may want to back off or change your method in how you're watering that tree, because it's probably going to end up killing it. So downspout drains are surface, obviously. Slotted drains are surface. Swales are surface. Culverts are surface, and rain gardens are surface. So everything that involves water on the property should be picked up in one way or another by some form of these devices to get the water out of where it needs to go. So this is the drainage pipe and fitting. So drainage material and piping often seem limitless, however, choosing the correct size and material for the application intended is critical. So the things to consider is the effective drainage, preventing water damage, durability, environmental issues, costs, and ease of installation and maintenance. I can tell you for a fact that when COVID hit, imagine a 10-foot piece of pipe, a Schedule 40 pipe, that I could buy, well, I'll just tell you what my cost was. Say it was like $1.65 a foot. It jumped up to almost $6 a foot. Okay. But everything else that had plastic in it, or is made of rod, or something else, everything went up. So I was getting all these flash reports and saying, hey, pipe, sprinkler head, drip tube, this fitting, that. They were all going up 30%. 3 months later, another 30%. I mean, I thought, my God, we're going to price ourselves out of a job, because it's just everything done. But that's across the board, right? So the cost, honestly, the cost is a big issue. And so, like I said, if you want to tackle it, you're going to save paying somebody labor, obviously. But know that if you're going to hire it out, that there's going to be a cost associated with material and labor to do that, obviously. As a matter of fact, I just got, ADS came out and said that all of their N12 piping went up 30% last month. So,
Why is it going up?
honestly, without getting too political, I think it's straight up our movies. Everything is, and though we can't get product, we can't start lowering our costs in oil and gas and refinery production because everything's just tied up. So remember, all of this stuff, 99% of the stuff, it takes oil to make.
It
Okay?
takes what?
Oil to make.
Yeah.
So that's part of the problem, is that. I'll say anything else about it. Okay, so the pipe and fitting material this is basically what's typically used is PVC, that's all day long, right? This should be HDPE, high density polyethylene pipe, so the HDPE is basically like N12, and I'll explain that later. Concrete, which is really only used by developers and maybe the highway department, some cities use concrete pipe for that, right? And then metal, which is galvanized, usually are culverts, that's definitely more of the rural area. So that's not really, you won't find a lot of that in the city or anything else like that. Okay, so, this, we're gonna start talking about some material now. So that should have been SDR 35, my apologies, but anyway. So everything is based on a standard dimension ratio, which is basically the thickness of a pipe. Some pipe are thicker, some are thinner. Don't be fooled by a thinner pipe, thinking it's cheaper and it won't last. You would be surprised how resilient and how strong it is using the right applications. Okay, this is S&D. This is called sewer and drain pipe. So that is, this is sewer and drain. This is typically SDR 35. So it comes in solid, it comes perforated, French drain. And you'll notice that as a belt fitting, most of these pipes will come in 10-foot lengths of a belt fitting so that they are solvent welded or glued, and one goes into the other typically. And so people say, I've seen installations with the holes up, holes are down. That's how you do it correctly. Because what happens is these are typically used in the French drain application. So if you have a retaining wall, is it goes down to the footer, and you dig down to there, and you set and you don't just set this in the gravel. So this is what is a 4-inch pipe socket. So what happens is, and these come in 100-foot lengths. So as you take these, you will actually pull this sock over this pipe to protect those holes so they don't get clogged up.
Do you need an extra set of hands?
No, I think I'm okay.
Okay. Sorry.
I appreciate it. So anyway, so this goes all the way down, right? And then what happens is that there's filter fabric that you will line your ditch with. And in between that on top, all the way up, is where you put your backfill gravel. Backfill gravel does not mean pea gravel. Pea gravel will compact and you will have a nightmare because it will not allow water to appropriately come back up and spill into get to these holes. It's too tight. You need something, we call it sea rock. And this usually plus or minus 3/4 inch to 1 inch to 1 1/4 inch rock. It's non-angular, it doesn't lock together, it stays loose, but that's what keeps the backfill on that wall so that any water that comes in, it drains down that rock, down to the bottom, it rises up through the holes and runs out to your discharge point. That's how a French drain should be installed and designed to make it work correctly. Okay, so this, everybody has seen this. If you've ever been to any box, right? Home Depot, Lowe's, anybody, your hardware store, your supply place, everybody sells ADS corrugated pipe, polyethylene pipe. And personally, I'm not a big fan of it, except if I have a retaining wall that has a lot of curves in it, it's great, because you try to imagine, cutting this other thing up. I'm starting up here, and I gotta try to bend it, and I can't, so then I gotta put a bend in, I gotta put a piece, and I gotta put another coupling, and I gotta bend it. I mean, it would take all day to do that. That's okay, it works. So that is basically, this is perforated, and it comes with a filter sock on it already to go. So you can get a roll like that. It's in solid, perforated with a sock. If you buy it perforated with no sock, you should put a sock on it, or spend a couple extra dollars to get it with a sock, because these slots are different than what these holes are on the other pipe. These have slots all the way around the pipe. So when it sits in the bottom, it's going to get water coming in all over the place. Again, if you have dirt, if you have tight gravel, say P, it's too tight around the pipe, and it will not let water get in there like it should. So that's something to consider. The other thing that I don't like about that, and I'm trying to sound positive, like, here's just a small section of this pipe, right? This is a solid pipe, but you can see how flexible it is, right? It can bend. Now, the problem with this is, if you're running a long ditch, and you don't have a bottom of that ditch, I mean, cleaned out, tight like this, that tabletop, from the high point all the way down to the low point, if it's going like this, or if it has dips in there, this stuff is gonna follow that. So imagine if you have this thing laid out, and you've got a big dip in it. Now this thing's gonna hold water. I mean, you can hold water in this thing. So, that always is kind of a breeding ground for mosquitoes to some degree. I don't like mosquitoes. They like me, but I don't like them. But anyway, so that's a concern. The other thing too is because it is very thin. If you use this application in a very deep situation, I can almost promise you're going to get some collapsing of this pipe. If you're buying a tree or shrub of age, you're probably going to get a root going into it and clogging it up. That's why I see a lot of things fail is because of root intrusion. But it's not a bad product if it's just used and installed correctly. Okay, so I just wanted to kind of show this because this kind of helps visualize when we talk about forces on pipe, how much external force and internal force pushing out is. And so this is just a diagram. So what we're looking, sorry. So right here, so it's just a force calculation using external pressure PST. In thermodynamics involves understanding the ratio between pressure, area, and force. So all of this all works together. So when you have dirt, gravel, something, and you have this void inside here, you want to make sure that this would be your SDR, your standard dimensioning ratio, if you will. So that was the thickness of the pipe. So that was just a little thing I just threw in there. Okay, commonly used fittings. So obviously we all have seen these before. So that's a 90, that's a Y, it's a 45, it's a T, and that's a downspout adapter. So you can see the sizes that you've never seen before. So that's the 90-degree bend, right? So I don't use a lot of these except in French strains that would be, say, under artificial turf or something like that, where I'm trying to drain underneath the decomposed ground that turf is being attached to. Because if I'm having a grid, I can do this and do a 90, because I'm not taking a lot of flow and having to worry about it hitting here, backing up and coming out. It's generally going to drain out to where the low point is. A 45, I use, lots of these 45s. If you're going to make bends, it's easier to keep it going in an area like this, right? So when your flow comes, it's like a big curve without doing this. You say, well, I can save myself, a fitting, but if you have a lot of flow trying to hit this thing and turn a corner and go down that way, remember, this thing can go about 79 gallons a minute, and you're having to take that force, turn it, and go without trying to back up so much. So I always try to do the 45s. This is a downspout adapter. This is a sewer and drain downspout adapter. It's 3 inches by 4 inches. It's offset so that you can take this and put this end up close to the house. Offset it to where the pipe will clear the footing and everything else in the brick or whatever your outside is. And so you take your downspout, you take that bend off, stick it right in there, and then you pipe this out, and that's a connector that you can use for that. This is the ADS equivalent one. It's slightly offset, and you put that on there. And then all of these things have what's called a snap coupling. So what you would do is, if you had your pipe like this coming up, you would take it and push that in there. That's how that goes on.
Ooh. Ah.
So it's loose, right? So what you end up having to do is probably put some screws in to tighten that up. I'll tell you something crazy that if you've never seen it, maybe you think I'm lying to you. So most people, when they install this pipe and they have to put on a fitting, such as this is an ADS fly, right? So putting one here. This is couplings, and it's all wobbly. Well, how do you think they hold that together? Oh, this is cool. How do you think they hold that together?
Okay.
Bingo. That's it. And that's it. It's just enough to hold it together so that when you backfill it, it doesn't move. So remember, one is being held together with duct tape. One is being held together with solid welding. So longevity. So just let you know that.
Interesting.
If you have, this is a flexible coupling with stainless steel clamps on it. So if you wanted to go, say, from like this right here onto this, and you would use this through it, you mash up the other end of it in here and tighten it down, and that's how you bridge that connection. So if you didn't have a coupling in the field that you could do that with, but you could do that. Let's see. Okay. So this, let's see. Yeah. Okay, we'll go with that second. Okay, so this right here is what's called a pop-up emitter. So this is usually at the end of the line. Pipe comes, all your water comes in. It could be at the sidewalk, it could be at the curb, it could be in the middle of the yard, it could be wherever you think the low fluid can discharge. It's got a little poppet in here, so when the flow hits this thing, it's
Ooh. Ah.
too much flow on that one. So it pops up and it allows that water to pop out. The only thing about this you have to understand is that if you're kind of a positive slope, remember, if you're trying to mesh grade, so what happens is that pipe comes up to meet this, because this isn't really deep, right? So it has a sag in it. So, and there's a hole in the bottom, and if you wanted to put gravel in there, anything that got in there could free drain into the gravel. But that's what, these are okay, but like I said, I would rather see you go through a curb or to a creek or some other type of an area to discharge. When we talked about the speed drains, well, wait, so let's talk about the French drain. So a tile drain is also called a French drain. So what I do is, I'm just going to give you a bait. This is how you can calculate how much of this gravel you need, right? So we dig about 1 foot wide, right? And I use an example of this was 2 foot deep. And we're gonna go 250 feet. So basically that's 500 cubic feet if you do the math. If you divide it by 27, which turns that cubic feet into cubic yards, it's basically telling you that to do your project with this dimension, you're gonna need almost 19 cubic yards of this rock right here to do that.
Oof.
So that's good to know if you're planning, if you have a French drainer, you're wanting to do retaining wall with French drainer, if you're wanting to put in a French drain in an area where you think you're gonna have surface water saturation and you think that that's gonna be the best method to drain that, you're gonna have to know how much gravel you're gonna have to order. Again, 3/4 1 inch, 3/4 inch and a quarter. Filter fabric, which will be around this through here. This is what's important. You want a non-woven geotextile fabric, meaning you don't want landscape fabric where you can buy it out of a roll and hold it up and poke your finger through it. You want something that's going to have some strength. It's non-woven, so you can hold it up. I can see light through it. That's going to allow the water to go through this and hold that gravel in place between the soil and in the gravel ditch. So that type of fabric is important. Okay, so this is what I was telling you before. Here's a pipe, but here's a pipe sock on it. So even though there's no gravel in this example, they put this on here to keep any amount of this dirt or debris from getting in there and clogging up those perforated slots. This is a typical 12-inch area drain. So these are used in lawn areas primarily, and they go 9-inch, 12-inch, 18-inch. I mean, I've had projects where I specified 24-inch and 36-inch drains. Remember, I'm in Tyler. It's hilly. We have a lot of flow. And so if I have a project and it's coming down like on a 5% slope or greater, I got to have a big box to catch that in the floor. This one here like this, which is typically, this is a 12-inch drain box, right? If you get one, this is typically what you're going to end up buying. You're going to get it with a plastic grate like this. You can come in green, you can come in black, you can come in tan, you can come in a multitude of patterns. But here's the problem. You see the openings on that? That's what I specify.
Ooh,
Big difference.
could you hold them side by side for those online?
Absolutely.
Thank you.
So this is, you think, my God, that's a big break. Well, okay, but if you have an area where you have a lot of leaf litter, grass clippings, twigs, trash, anything that's going to flow, when it gets seeped down on this thing, it's going to start sucking down on it. It's going to cause that water to just back up. I can promise you, I've never had one of these fail unless there was a log to try to get through this thing. This will pass just about anything and everything that I can tell you for a fact in East Texas that we have. I mean, I'm talking about anything pine, it will pass it. Leaves, grass, dirt, sticks, it passes it. So,
Do you buy that separately then? Or?
actually, if you, I can tell you on some suppliers, it's called an NDS 1200 MTLKIT.
Can you do that one more time? I'm so sorry. I'm typing it for an NDS.
NDS
Okay.
1200
1200
MTLKIT.
KIT.
It's a 1200 means 12-inch metal kit, and that's what this comes with. And all of these drain boxes, you can specify single outlet, a double outlet, triple outlet, there's a bottom outlet. You can get all the different kinds of fittings and plugs based on your application. Now, something that we have done, because we're the premier landscape company in Texas, we're powder coating some of our green.
Ooh. Ah.
So, this, you say, well, gosh, if the grass turns brown, it's gonna yeah, but it's a little more aesthetic than, say, the galvanized one. It's whatever your purpose is, but we just find that some of our clients like to have this. So this is a little bit greener, honestly, than we want. We're going to go for another batch that's just a little bit darker to best replicate Bermuda a little bit better, but this was an idea that I came up with, like, let's powder coat these things that would agree. So that's what we're doing. So something new, nothing patented, so you can do it if you want. And so here we are, we're talking about this right here again. So, whoops, you gotta see this, right? That's my go-to to everything that I design. And if you look at this grate right here, and don't let this fool you, this thing will pass 384 gallons a minute through that grate and in that box. But again, on the other side, because the boxes have different size knockouts that you can put pipes. So if I had, let's say that I had this application, but I had 100 gallons a minute coming into here, which I know it'll support, I would have to change this 4-inch to a 6-inch because a 6-inch will go up to 180 gallons a minute. Yes, ma'am.
So if it's big enough to let the leaves and the pine needles and such through, does the pipe get clogged, or does it sit in the bottom of that where you clean the box out?
This will. This won't. That's smooth. This pipe here has. You hear it? It has. It's just like the outside. It has voids in it. So as the debris gets in there, it will set in those voids. That's why I said if you have a low spot and you have debris going through there, it's going to sit in that low spot. It's not going to pass maybe 100% through. So,
Does it sit in the bottom of that box though, since you've got space?
it can. It has a sump in there, and may have to require just a little bit of a maintenance just to pull that grate off there and maybe clean it out, put it back on, and be done. That's it. So it's pretty easy. But like I said, that's I use that all day, every day. Okay, this is what we're talking about. I was going to show you the speed drain. So this is a speed drain. It's a little bitty, cute 6-inch little drain. And typically you use these in beds, right? So it's just, again, a little drain, and it has 4-inch, 6-inch that you can put in there and knock out. And it has, you can get them with a flat grate, which handles about 28 gallons a minute through this. Or an atrium grate on there. And that's what you want in the bed, especially you got mulch, right? Because now if it floats up, it's not going in there. On the other one, if it floats up and sits on top of this, guess what? It backs up. So again, it's the application of what you think you're going to need to make it drain correctly. These two, single, double, triple, however your application is. But the problem with this is if you're running these in series, that's what you get, right? So your pipe stays, I mean, if this is the top, your pipe is just barely below the grade of the ground. And you're going to have to run these things together and link them up. You don't have much slope because these are all the same size. So the other one's going to be sticking out here. So when you set this one, the one here goes over here, you're going to go to here, you're going to go to there, and you're going to use whatever grade. There's not much slope in the pipe at all. So what we do is, we take this, which is a 6-inch by 4-inch reducer. So we put the grate on there, and we take our pipe, and we stick down, stick a fit on there. Now, what happens is, if we're running a long bed, we can run this one shallow. If we come down, we can make this deeper.
Ooh.
Now we have slope. Now we drains. That's the key to it. Is that you can set this at make it drain in your application. So, speed drains are great if you're gonna use one or two, but if you're gonna use a lot in a series, then I would highly recommend this. Using something like this. You know, the cost is not that much more, but I think you'll benefit out of it greatly. Now, I didn't bring this because this is too big, so. These are channel drains. So the channel drain is basically where, obviously you can see here's a garage. That slopes pretty rough, but if we were gonna go back up this way, let's say there's a driveway and we were coming down and whatever, and there was a lot of water through here, you can install this channel drain, and what it does, it just intercepts the flow, so there's nothing ponding through here, and then it either will have a pipe, a bottom outlet, will drain this way, or you can drain that way. But that comes in a multitude of sizes, right? And you can use these channel drains. If you guys have swimming pools, you may find a little zip drain or something like that. It's a channel drain. Same thing, just a smaller grade. So they go small. They can go anywhere up to, typically use maybe a 5-inch or something like that. Some properties that we're doing drains in, we're doing 12-inch wide cast iron grates. Because it's like, again, out there it's a lot of slope, and we want to catch that water and not have it skip and get into the house or the garage. So these are really good. But the kicker is this right here, the grate size and the pattern type must be sized accordingly to accommodate the inflow. Grates are vehicular and non-vehicular rated. So if you're doing this, definitely want to get something that's galvanized or cast iron. Using something in a pool or a walkway or something, they make plastic grates. And I'm telling you, you can get any color and pattern under the rainbow, and it's great for your application. But again, you got to make sure that the inflow of whatever that grate will handle in gallons per minute is going to be sufficient to allow whatever water that you have coming down to be able to get into that channel and drain. Or else you're going to have a backup situation on that as well. This is a typical gutter downspout connection. You know, there's that downspout adapter. This is blue pipe. It's white, but this is probably SDR 35 or SDR 21. So you come down, they use that 90. That's exactly how we do it. We do it like this with a pipe with a 90. We come out, and then we tie it into our line. We always use a line. We never use a T, because the flow of water coming around intersects right through here, and we get no tailwater back up at the downspout area, which would be here. And sometimes you see water shooting out of here, it's because it's a hard 90 or it's a T, and the flow coming down will not allow it to pass into the pipe, and it will start shooting out of this right here. Again, a T I would use this T situation in a French drain, because again, I can connect runs of perforated pipe that catch slow infiltrated flow into the T and let it drain. I would not use a T on something like that, because I think that would be a problem in the long run.
So
Yes.
you would cut, usually when the installer has put that, they have kind of descending. So you just cut that over there and then add this pipe.
Yes. Give you that.
This, yeah.
Yes. So this right here is like, what is the difference between surface and French drains? When is it correct to use a French drain? So we're gonna establish between the two types. So surface drains are drains designed for surface water, which is cooling, much like during or after a rain event. These drains typically have some type of inlet or catch basin, which are installed typically at low points or along path of surface flow to intercept and catch the water into the basins, and is then piped to carry that flow away to a discharge drain. The surface drain should not be connected to a French drain, because remember, a French drain is low percolation into a gravel bed that comes up and runs. And if you have that doing its thing and you're running a downspout system through it, man, you're like zipping water through that thing, and it's just, you know, it's too much to handle. And I think what you're going to find is is through those holes, you're gonna have water trying to come out of those holes. It'll make it really wet. Again, here is it. The eventual debris from the surface drain, mud, rocks, grass, leaves could eventually contribute to clogging the discharge holes in a French drain piping. Installing French drains in an area that stays soggy will not correct the problem. It will only allow water that has surface to flow away or evaporate over time. The soggy areas will stay soggy and continue to be a nuisance or mess. So again, I would say this: if you are on social media a lot, there's some drainage pages and this, that, and the other. And I get on, I look at this stuff, and I type my comments on there. And my wife says, "Who you email or text it at 10 o'clock at night?" The comment. So it seems like the buzzword is that French drains solve everything. Obviously, you've seen, we've talked about this. It's not the one drain catch-all to solve everything. And the French drain is installed for subsurface water conditions, typically in an area that stays soggy for extended period of time, such as days or weeks after a rain event. And typically, design installation application would be in the valley behind a retaining wall or along a foundation. So, again, that's the two comparisons between the French drain. A typical French drain installation would include a trench deep enough to intercept the flow of water or to store any freestanding unwanted water. Within the trench, there should be the correct filter fabric applied to accept the water, but not the debris, the soil. Proper size drain rock, but never use pea gravel. Large drain rocks allow water to percolate and infiltrate freely to the piping, whereas pea gravel or no gravel at all will allow hydraulic constriction around the pipe and possibly prohibit water entering into the pipe. So that's what we talked about in that. Poor soils are typically reached for a French drain. Frenching can be piped into a surface drain, as the flow of water in the surface drain typically is faster than can wash away. Again, the surface drain would be a yard drain, a bed drain, but not the downspout rip drain. That's too much velocity. And never connected, obviously it's pretty, oh, I'm sorry, yes, ma'am.
Where is this water moving to? Is there a collection place for it? Is it joining the main system, the gutter street? Is there a reservoir? I know in the northeast with snow and mountains like that, they have, a lot of times they'll have those large reservoirs for the water, but, where are you putting it in East Texas? Where are you moving it to? Not somebody else's property, because I was gonna say.
Right, a lake or a creek, or through the curb out into the street.
Yeah, stormwater system.
Mm-hmm.
This is why Fort Worth has a great stormwater system, just so you know.
We flush it all out, right?
Yeah.
Anyway, hydraulic loading is the hydrostatic pressure behind a retaining wall. That's probably pretty self-explanatory. So what it is your retaining wall, right, is vertical, and so it is slightly cantilevered back for strength, whether it has ties in or not to keep it from tilting forward. But what happens is that the hydrostatic pressure is the pressure behind the wall that exerts forward on the back of the wall, trying to tip it forward. And that's why you want to try to get all that water out of it, because the heavier soils, they put too much force on the back of the wall and try to chip it over. So that's why the gravel pressure is important behind a retaining wall, especially when you talk about hydrostatic loading. Here again, we just so drainage, it's solid percolator behind the wall to collect channel. Channel water away from the wall from the method of managing hydraulic loading, proper backfill, wall design considerations. We have hydrostatic pressure, we have the surcharge load. This is some engineering type stuff anyway, and active pressure, right? So that's another big deal there. And I think that's it. So, depends on how much flow's coming down. I don't like that. If it hasn't caused a problem, I hate to say this, I might not worry about it, but if it does, you want to take that off and pipe that separately and not let that go into the first drain. Yes?
For example, as a solution to that, could you possibly run a NDS pipe or a smooth bore pipe right next to the French drain and then flow it that way?
Absolutely.
If it causes an issue.
That's
I
right.
think.
Yep.
Okay, we have, the two projects here, and one of the sits in the middle of both of them. And they put out, I don't know who it was that came out, but they put a drain in. French drain.
So typically, what happens is we have two houses. Okay, so let's look at a scenario maybe more in some. Let's say you live in a subdivision and you have neighbors on both sides. You have guttering and downspouts, and they go down and they turn out and they got maybe 10, 15, 20 feet behind between your properties, right? It goes down into a little swell and it's supposed to run into the street or back to the back of the property. Typically what happens is that those soils are not compacted like they should, and over time they start to do this. So as the water runs out of the downspout, it will run, and then it'll start standing between the houses. Is that what you're saying? It's because the soil is not compacted.
So we need to dig it back up and put gravel in there or something?
No, what I would do is maybe take the low spots, and then what I would do is move the grass, put in some topsoil in there, pack that down, and lay the grass back on it so that you're actually bringing that dip up to grade so that the water can pass through. You know, if you have problems like that with your neighbors and you're in good terms with your neighbors, you could also take and split a drain system, right? You could run solid pipe between the houses, and then you have a shared cost for that. And then you pay for your downside, then you pay for your downside, and then it reduces the cost of the two people not on the cost. So you look at that.
What was the question? I'm so sorry, I couldn't hear.
The question was that she has a problem where she has a wooded area at her house, and she wanted to know how far away was far enough away that would be okay.
Got it.
I think it depends on your comfort level, number one. Number two is that what is the impact? If you have dogs, or they're always bringing in mud, and you have kids that play out there and they get muddy. Is it put on the foundation? How close? Not too close. But I mean, again, you may want to cut that out, bring some dirt in, raise it up a little bit, have it blended, grass back on, and then you should move in the water. You know, that thing too about all this excess water too, especially around the foundation, the primary cause of foundation damage is excessive water, and because when houses are built, even today, clay soils are brought in to make the foundation for the base that you're going to put the concrete on. And so they build the house, now you have all this red clay again, when it gets wet, it shrinks, and it swells, and when it dries, it swells, so you have this heating factor up and down, and that's what's causing the foundation to crack out because of that. Again, French drain around the foundation or downspouts to get your water from the roof out away from it is probably your best solution. Yeah, if you do a downspout drain, tie it into the water out of there, then you're trying to remove all the excess water. No, solid drain. Or you put a French drain along the side of the house that you maybe, like if there's a slope and water's coming down, you put a French drain to intercept that water. You just have to remember that everything we're talking about is especially like, you know, when we were coming in, I said, dang, I'm in this class about water, it's hot and it's dry, and, you know, this would be more suited for like irrigation, right? But not, you know, if it was thunderstorms, it hit home a little bit more. So, well, what I do in day to day is I do everything that people don't see, right? Everything that I do is below the ground, but everything that I do, you will see if it's not done right. If I don't irrigate correctly, your plant material is bad in your grass, you're going to notice that. If I put a drain system there, it don't capture all your water, so you have foundation damage, you have water sitting in your yard, you're going to see that. So there is a correlation between the two. Even drains, like I said, in the bed, if you're irrigating, if you consistently run your irrigation, which you shouldn't be.
Please don't. That's not allowed.
If you
Don't do that.
Or if you had a valve that's stuck on, right? I say this, anything man is going to fail. It's just, you put the valve, the whole hangs, and it's going to spray, and you're sleeping, you wake up the next morning, and you look out, and there's a lake in your bed. You know, maybe a bed drain would solve that. It would at least drain that water out of there, and there's some hope for your plant material. So there is some direct correlation between a rain event, irrigation cycle, and drainage. Yes, ma'am.
Like what you have pictured on your back up there, so that's like a rain garden.
Yes.
Coming down from I'm just gonna say there's it's coming from a downspout, the water's running down. But what, you mentioned a type of rock, earlier, something about sea rock.
Yeah.
What, do you find that using larger, rock is better than?
No, using smaller rock for the French drain is better.
Okay.
This is basically river rock. So you're going to have pieces like this, right?
Mm-hmm.
So if you look, this piece is probably coming from either a downspout or maybe it jumps across, it's running down here. But if you look, there's a little speed drain right there. So all that water's come down and goes right in there, and it's being piped out somewhere. Good.
So would you use river rock for a basin if you have this French drain empty into a basin?
You could, yes.
Could you repeat that? I'm sorry. If you have.
The question was, could you use river rock at the end in a basin for the discharge of a French drain? And the answer would be yes, you could do that. Yes, ma'am.
So, since it's already been installed, the perforated drain that you don't like, it was not the best thing for sure, because even just the granules from the root that came down and put it into it, and then I'm guessing some tree roots or something too, because it goes down and across, has gotten clogged. How do you unclog it?
You dig it up.
There's no way. I know, I don't mind digging, but it's behind a rock wall, so there's just.
See, that's what I'm saying. I mean, you know, and I'm proud of the fact. I mean, I put in everything I can in my house, and it's getting hard for me. And it's like, I get it, but there are limitations. You know, we're talking about root intrusion and collapse of pipe. You know.
Because you can't use like a plumber sink, that would just tear the pipes.
Yeah, because this is really thin wall pipe, right? I mean, I could go right, stomp on this right now and crush it. I could stomp on these if you make it less, if you mark that. I would crush these. So imagine over time, tree, shrubs, like you said, there was granular, asphalt granular from your roof. It's in there. And these pop-up emitters, I mean, because I said it comes up to this because it has to meet grade. You could pop this top off and look in there, and I guarantee this is full of your granular stuff, or mud or sticks or something. I mean, it's just, there's like anything, right? There's maintenance behind it. You're going to have to do a little maintenance, keep it clean, keep it strong. But that idea is take down one water, put some water, another.
Okay.
But I'll come over and I'll just watch the.
I want to say thank you again to Jon for being our guinea pig for this new class. I learned more. I hope I'm as excited to be dating this weekend. That's fine. We're in it to win it, so we'll do it together. So again, one more round of applause, please.